So now we're on to 12.2, arcs and chords. So the first thing we need to know is about a central angle. A central angle is an angle with vertex at the center. So for example, angle APB. So any angle that has the vertex at the center of our circle is a central angle. So this angle APB. And some of this stuff should be familiar from when we looked at the chapter 10 with those arc measurements. So a minor arc is an arc that's less than 180 degrees. It's equal to the central angle. And we use two letters. Use two letters for minor arc. So a minor arc AB would be this one. Remember that arc measure. So if this was, say, 85 degrees, then this would also be 85 degrees. So the measure of the central angle is equal to the measure of the arc. A major arc, an arc that's greater than 180 degrees. And for major arcs, we're going to use three letters. We use three letters to describe major arcs. Notice that ACB, the first letter is going to tell us where we start. The second letter gives us the direction. And the third one is where it ends up. The arc measure is still equal to that central angle, so it'll be the measure of that layer. So if that was 85, 360 minus 85 is going to be the measure of ACB. So this would be 275, equivalent to that measure as well. And then a semicircle is an arc that's equal to 180 degrees. So let's take a look. MN, right? This arc measure right here. If that's 80 degrees, if NRM is 80 degrees, then MN also 80 degrees. See if you can figure out the measures of the next two. All right, so MPN, going the other direction here, MPN all the way that way, is going to be 360 minus 80, or 280 degrees. And then PMN, starting at P, going to here, that's half of a circle, or 180 degrees. All right, so our arc addition postulate, the measure of an arc formed by two adjacent arcs is the sum of those arcs measures. So if I want to figure out what GE is, I can add 40 plus 1 plus 80. And I get 120 degrees. GEF, that's my grade. I'm going to add all three of those together. So 40 plus 80 plus 30, 110 degrees. I get 230 degrees. And then GF, I want to solve for this minor arc. I can take 360 and subtract that 230 from above, I get 130 degrees. Questions on that so far? Next, it turns out that the perpendicular bisectors of two chords the segments going to the center are equal. So x is going to equal 16 here. Right? The way this sets up and why that is the case is I created right triangles in here. We know that these guys are congruent because the radius of a circle only has one radius. So if I have two different radii of a circle, they must be congruent. So these two triangles are congruent by HL, hypotenuse leg congruence theorem, right? We have 18, 18, and then the hypotenuse are congruent. So these guys must be congruent as well. All right, so we're going to draw some circles for these different theorems. So, in a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. Let's go ahead and draw a circle here and see what we have. So, center C, A here, at DE. All right, so if diameter AC is perpendicular to chord DE, then intersection is going to be B right there. Then DB is congruent to EB. And arc AD is congruent to arc AE. Next one, let's draw our circle again. Again, I'm going to set it up just the same. Center C, there's B there, D, E, and A. So in a circle, if a diameter bisects a chord that's not its diameter, then it's perpendicular to a chord. All right, so if this is bisected, then that's perpendicular. So if DB is congruent to EB and AC is a diameter, then AC is in fact perpendicular to D. right. Let's draw our diagram again. AC, D, E, G. So now, in a circle, the perpendicular bisector of a chord contains the center. So, if AC bisects DE, then AC must be a diameter. Example 4. In circle O, AB is a diameter and is perpendicular to chord CD. We know it's a diameter, goes through the center, and is perpendicular toward CD. What conclusions can we draw? Well, we can draw a couple of conclusions. First, these guys are congruent. EC is congruent to EE. If it's perpendicular, it must bisect that chord. And then we also know that arc CB is congruent to arc DB. All right, that is all for 12.2.